So the big idea of chapter 1 is all about how we use algebra to describe, and the language of algebra is much more efficient than words. So once you know the symbols of algebra, and once you know how to put variable expressions together to write equations, you can be really, really efficient. So for example, a way to think about it is if you had to explain to someone how to multiply the fractions 1/2 times 3/4, you could use a lot of words. You could say you take the number on the top of the first fraction, the 1, and you multiply it by the 3, and that equals, and that's the numerator 3, and then you bring over the fraction bar, and you multiply the bottom number 2 times 4, and that's an 8, and that gives you the answer 3/8. But if you write it with variables like a over b times c over d, it's simply ac over bd. And you can write it very, very efficiently just using variables and symbols rather than all those words. So that's the big idea of the chapter. Another way of thinking about it is if you're going to describe to somebody who's blind what's in this picture, it would take a lot of words. And that's where we get this saying, a picture is worth 1,000 words. So just showing this picture gives you so much information without having to use all those words. Well, that's what algebra does for mathematics and for problem solving. It's a really efficient way to use variables and symbols and numbers to communicate a lot of information in a very short amount of space. So another thing that we talked about that algebra does is it makes it possible to find a pattern and generalize and use that to have infinite answers. For example, if I told you that my pattern is that I'm going to double a number x to get y, we could have put in any number we want for x. We could put in 5. Shadia put in 5 and she got 10. Omi put in 8 and he got 16. Stefan put in 16 and he got 32. And I forget what number I gave Tyne, but anyway, the point is that, oh, I think I gave him 20, and 2 times 20 is 40. The point is that you can find infinite y's for infinite x's, but the pattern amongst all of them is that whatever y is, it's always 2 times, twice as big as the number you had for x. So that's just a simple way to see that it's the language of generalization. So we reviewed some things from grade 7 today. The order of operations. Some of you knew please excuse my dear Aunt Sally. Some of you knew PEMDAS. But the important thing is that you always do what's in brackets first, and then exponents, and then you either multiply or divide from left to right. You always do this from left to right, just like reading a book in English. You go left to right. And the last thing you do is add or subtract from left to right. So make sure you do those last 4 operations in the order you see them from left to right. All right, and then we talked about evaluating an expression. So to evaluate an expression simply means to figure out what the simplified answer for that is when you substitute numbers for the variables. So if A is 5 and B is 2 and C is 3, and I want you to evaluate A plus BC, you take out the A and you put in 5. So this A becomes 5. I bring down my operation addition. And BC means to multiply B times C. Well, B is 2 and C is 3. So now I've changed this variable expression into a numerical expression. And now I just simplify. That's what evaluate it means. So I say, I don't add before I multiply first. 2 times 3 is 6. And now the last thing I do is the addition, and 5 plus 6 is 11. And remember, you go down your paper like this. Think of that upside down Christmas tree. And then the variables in the expression, you guys, we talked about variables. Variables are where we are letters that we use in place of a number. So the variable is A, the variable is B, and this means 3 times my value for A, and then I add whatever B is. So this is called a variable expression because it has variables and numbers and operations. And they're called variables because the word vary, V-A-R-Y, means to change. And I can have B represent 2 in one problem, and the next problem I can have B equal 1/2 or B equal 1,000. So it changes. We can change the value of B. All right, and we talked about how you can use a variable expression to represent this rule of thumb. Most adults are twice the height when they're an adult as they were when they were 3 years old. So if we let C equal the height of a 3-year-old, you can write a variable expression to represent the height of an adult. So if I'm going to be twice that tall, I represent that as 2c. So that's what this means. Take my height when I'm 3 years old and double it, and that's the height I am as an adult. So these are all variable expressions. CD, which means c times d. 4 times x divided by y, that's a variable expression. X squared is a variable expression. Notice that all these expressions, they don't have any equal signs. If they had an equal sign, it would be an equation. Then you practice. If a is 5, find 3a squared. Remember, a squared means a times a, and 3 times that. So really, what you're doing is 3 times 5 times 5. And you do the exponent first, so that's 25 times 3, which is 75. This is a very different problem. This means 3a times itself, 3a. So this is going to be bigger than this. Notice this is 3 times a, because we just squared a, but this is 3 times a times 3 times a. So this is 3 times bigger than this. Notice 3aa, 3aa, and another 3, and it's a multiplication. So it's really this answer 3 times bigger. So you do 3 times 5 is 15, and 15 squared, and we use the x squared key, is 225. And then we talked about how you could use this exponent key to find any exponent. So this was 15 squared, and you have a key on your calculator, that's the squaring key, but you also have this little tent looking key that's an exponent key. So if you put in 15 and then the tent key 3, you got 15 cubed. 15 and the tent key 10, Shadia wanted to know, could you do that? Absolutely. That would be multiplying 15 by itself 10 times, using 15 as a factor 10 times. So you used your calculator, and what you got in your calculator is an answer in scientific notation. So it was something like 5.766 blah, 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 times 10 to the 11th. Some of your calculators might then say E11, and this part's really important because it means the real answer to 15 used as a factor 10 times is really this number, 5,766,503,000,000. Not, oh, I think I put my commas in the wrong place. Sorry. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. No, it's 576,650,390,600. So you'd have to move the decimal from what you saw in your calculator 11 times to the right. That's what that 11 means. So we had to tack on 2 zeros to get the real standard number for 15 to the power of 10. You did some practice, making sure you understand the differences between these problems. So this one is 4 times 2 times 2 times 2. You do the exponent first, which is 8, and 8 times 4 is 32. And as Tyne said, this is just the opposite of it because b cubed is still 8, and 8 times negative 4 is negative 32. And this one's very different. Now we need to do the brackets first, so negative 4 times 2, which is negative 8, and then cube that. So it's negative 8 times negative 8 times negative 8, which is negative 512. And then we talked about evaluating these expressions and going down, showing your steps. Think of this as an upside down Christmas tree. So first thing you do is take the problem and substitute 2 in for x. So we took out x here and put in 2. And then you do the brackets first, which gave us 10. Then you multiply 3 times 10. And the last thing you do is add the 25. But notice we keep bringing down those steps so we don't skip any of them. And at the end, the answer is 55, so give it a circle so you know that's the answer. That's your simplified solution. And then 3 to the power of x plus 18, substitute your 2 and do your exponent first and your brackets first and make sure you add last. So you get 29. Then we did some problem solving. Suppose a and b are whole numbers and a plus b is 100. What's the largest possible value of a plus ab minus b? So we talked about, gee, that's kind of a hard problem when you just look at the whole thing and you really can't answer it with a snap of a finger. So you've got to go back to those steps of problem solving. And step 1, which you guys didn't really remember, is just understanding the problem. So what we're looking for are 2 different numbers that add to 100. And when we take the first number and we add the product of the 2 numbers and subtract the second number, we have the biggest possible answer. So step 2 is make a plan, and Tyne came up with this plan. He said, well, it could be 49 and 51, or 48 and 52, or 47 and 53. And I said, well, what if you continued that pattern down? Like, what would happen when you got to the bottom? And he said, oh, 99 and 1, and then 100. Whoops, this should be 0. 100 and 0. And when you get to 100 and 0, you can't have anything else, because if this is 101, I don't have a whole number that I can add to 101 to get 100. So this is the extreme of the two numbers being the furthest apart, and this is when they're closest together. Remember, we can't have 50 and 50 because the variables are different. So then the second part of that plan of making a list is, okay, now we've found this plan, so let's check. So we divvied this up, and Shadia did this one. She used 100 and 0, and she got, this is 0, and 100 plus 0 minus 0 is 100. Omi did this one. He multiplied first, added 99, subtracted 1, and got 197. Stefan did this one, 48 times 52, add the 48, subtract 52, and he got 2,492. And Tyne did the first guess that he had, and he got 2,497. And we know it's the biggest because all of the other combinations are going to be between these. They're going to be getting smaller than 2,492, but bigger than 197. So excellent problem solving. And step 4 is looking back. And we know, well, step 3 is carrying it out. So we did that. Step 4 is look back and make sure you know your answer makes sense. We can't get the numbers any closer together. We followed a pattern. We can't get them any further apart. So that means that this is the biggest answer and this is the smallest. So that was the correct solution to the biggest value is 2,497. Okay, we got started with this on class. Make sure that you fold your paper in half vertically, work down the columns, show your steps, especially when you're evaluating an expression. Show me what you substitute. Show me the upside down Christmas tree. And that's it. Have a great weekend.